This section examines the air supply. In multi-point injection systems, the air required for the combustion of the fuel is led from the air filter through the throttle valve and into the common manifold or plenum chamber. From here, individual intake runners or pipes branch off to each cylinder. All of these pipes are of equal length. The design of the intake system determines how large an air mass can be drawn into a cylinder at any given engine RPM. This is where most advantage can be taken of electronic fuel injection, since it can achieve exactly uniform distribution of the air delivered to the cylinders. With unobstructed passages to each cylinder, the cylinder fills with air as efficiently as possible. The breathing of the engine, or its volumetric efficiency, is improved. The more air crammed into the cylinder, the denser the air-fuel mixture when ignition occurs. This increases the thrust on the piston and increases engine power output too. The temperature of the air influences how dense the air-fuel mixture will be. Cold air is denser than hot air, so it has a greater mass in any given volume. This is why on most intake systems the air entry to the intake is away from engine heat, to ensure the entry of cool air. Since the manifold carries air only, it doesn't need to be heated by coolant. Filtered air arrives at the intake port as cold and dense as possible, ready for mixing with the fuel from the injector. The amount of air entering the engine must be measured, so that the amount of fuel injected into it forms a mixture to suit the engine operating conditions at that time. The volume of air entering the engine varies according to the position of the accelerator pedal and the engine speed and load. Changes in volume are reflected in changes in manifold pressure between the throttle plate and the intake ports. When the pistons draw air away from the manifold more quickly than air can pass the throttle plate into it, the pressure in the manifold falls. At idle speeds, this pressure is low. A high depression or a vacuum exists. As the throttle plate opens, the pressure approaches that of the atmosphere. The depression or vacuum tends to fall in value. Devices measuring air entering the engine send a varying electrical signal to the ECU. The signal can be a measure of the volume of air or of the manifold pressure. In both cases, this information is combined with the engine speed signal to provide the basic setting for the injector pulse width. An airflow meter measures the volume of filtered air entering the engine. It can be mounted on the air filter casing or close by. All air entering the intake flows through the meter, then through a sealed flexible hose or duct to the throttle body, then enters the engine. Vane-type airflow meters have a spring-loaded vane or flap, which deflects according to how much air enters. The electrical signal to the ECU varies with this deflection, as contacts attached to the vane move across a potentiometer. The intake system must be airtight, with no leaks downstream of the meter, otherwise inaccurate signals will be sent to the ECU. Manifold pressure sensors measure pressure in the manifold. One common type has a small connector